Hey everyone, we are going to do some more normal distribution problems. We're not going to learn anything new today. We are just going to do some more examples. We're on page 31 of your course packet, and we're going to start off with the example at the bottom of page 31. Men's heights are normally distributed with mean of 68.6, standard deviation of 2.8, and a standard doorway is 75 inches tall. Okay, so first question, we want to know the percent of men who are too tall to fit through the standard door without bending. So here's my normal curve. I'm centered at 68.6 and the doorway is 75 inches tall. So anyone taller than 75 would be too tall to fit through the doorway without bending. Okay, so we're going to do it by hand first. I want to first calculate my z-score. So I take the value I'm interested in minus the mean and divided by the standard deviation, which in this case was 2.8. And that's equal to 2.29. And I'm going to go to my normal table and look up a z-score of 2.29. So here we have 2.2, and then I'm going to go out to the very last column. And so you can't see it, I'll move it over a little bit. It's 0.989. Okay, so back to my problem. I know that the area to the left, that's the area that the table gives me, is 0.989. But the area I want is the area to the right, because these are the people that are going to be too tall. And so to get the area to the right, I take 1 minus 0.989. And that gives me an answer of 0.011. And I can do that on my calculator. I want to go to second, and then VAR, normal CDF. Now I always want a lower bound and an upper bound. So my lower bound is 75. When I want the area to the right, I just put in a really large positive number. So a bunch of 9s, comma, and then I want to put in the mean. And then I want to put in the standard deviation, so 2.8. Okay, so lower bound, upper bound, mean, and standard deviation. And that gives me 0.011135. Okay, so very close to what we got using the table. Next question, a little more difficult. If a statistician designs a house so that all the doorways have heights that are sufficient for all men except the tallest 5%, what doorway height should be used? So this is a little different in that we want to find a value for x. So here's our picture. We're looking for this value, and we want the area to the right to be 0.05. That's because this value for x that we're looking for represents the tallest 5% or the 95th percentile. Those are the same things. So if we're going to do it by hand, we want to find the z-score and then use the formula x equals a z times sigma plus mu. So the first thing I want to do is get the z-score. The table gives me the area to the left, and so we want to look up the z-score for having an area to the left of 0.95. So remember, when you're using the table, the areas are within the body of the table, and so I'm going to do this backwards. I'm going to look up 0.95 or whatever's closest. I could use either of these numbers because they're just as close, so I'm going to use 0.9495. Now I want to get the z-score, so I have 1.6, and this turns out to be 1.64 if I scroll up. 1.64. So my z-score is 1.64, and that's really all I need. Now I can use that formula to solve for x. So this is going to be 1.64 times 2.8 plus 68.6. And that's equal to 73.9. Okay, so you can follow along down here. The final answer is 73.9 inches. That represents the top 5% or the bottom 95th percentile. To do that on my calculator, oops, that's not my calculator. My calculator disappeared. Let me bring it back up. Okay, there's my calculator. To do this on your calculator, you go to second, VARS, and then we go to inverse norm. This is a type of problem that we're working backwards, so we call this an inverse problem. And for one of these, I put in the area to the left. The area to the left is going to be 0.95. Then I put in the mean. And then I put in the standard deviation, 2.8. And that's it. So area to the left, comma, mean, comma, standard deviation when you use the inverse norm. And I get 73.2. Not exactly what I got using the table, but the table you have to allow for some rounding error. Okay, so let's go to the next problem. According to the Centers for Disease Control, the mean total cholesterol for men between the ages of 20 and 29 is 180. A healthy cholesterol level is less than 200, and then above 240 is dangerous. For a randomly selected man from this group, what is the probability that his total cholesterol is 200 or more? Okay, so I have my picture here. I have 180 in the center. Here's 200. So 200 or more is going to be this area right here. I want to get a z-score for that. So I take 200 minus 180 divided by 36.2. And that's going to be equal to 0.55. Then I'm going to look at the normal table, and I'm going to look up 0.55. So here's 0.5, and here's 0.55. So the area to the left is 0.7088. Okay, so that's this area right here, 0.7088. I know I want the area to the right, and so I need to subtract from 1. And so I get 0.2912. Oops. And I can do that on the calculator. I go to second, variable, normal CDF. Now I want a lower bound. That's going to be 200. An upper bound, since this area to the right, I just put in a bunch of 9s. Then I want the mean, and then the standard deviation. And then I hit enter. And I get 0.2903, very close to what I got when I used the table. They're going to be slightly off from each other because the table rounds. Okay, this one, number 2, is the same as the first one. You're just using a different value, 240 instead of 200. Let's go down and do the last 2. So what is the 95th percentile? This one's similar to what we did before. The 95th percentile means the area to the left is 0.95, and we're looking for the value for x that corresponds to that. So I want to get my z-score. I know that's going to be 1.64. We just looked that up. And so I want to put that into the equation. X is equal to 1.64 times sigma, so times 36.2, plus the mean, which is 180. And that's going to be equal to 293.37. That means 95% of individuals have a cholesterol level below that, 5% have a cholesterol level above that. And on the calculator, I would just go to second vars. Now this is an inverse norm problem, so I hit enter for inverse norm. Area to the left is 0.95. Then the mean is 180. And standard deviation is 36.2. And I get about the same answer. And the top 5th percentile is the same as the bottom 95th percentile, so these two answers are going to be the same, 293.37.